So, reminder what we talked about yesterday. The progress check is open, but you have 2 weeks to get it done, including 1 day in class the first Monday, the Monday we come back. So bring your laptops that Monday. There'll also be a homework check that Monday at the end of class. You can work on the progress check, any of your homeworks. I'll wait till the end to do the homework check. You can also ask to see your test and go over what you got wrong on the test. You know, you can go into College Board, AP Classroom, and go to any of your old quizzes. We can go over any of those things you got wrong. Whatever you need help with, that's a great day for it. Okay, so that's just a reminder. I went over it yesterday. All right. Also, everything we talked about yesterday is in effect today, and we're going to kind of go over those key points right here in this box. And then we have a different type of problem than what we did yesterday, but much easier. I think you guys are going to see. Okay. So, what we started talking about yesterday was inverse functions, okay? Number one concept, what we have to understand, the most simple, basic thing about inverses is that they are reverses of each other, meaning the x and y's in your function flip or switch in its inverse. We see it in tables of values, right? We could just switch the x's and y's. We could see it in a graph, just flip the x's and y's, including the domain and range, right? The domain and range of a graph would flip in the inverse, because it's x's and y's. It's all about switching x and y, okay? And then we also did in equations yesterday. We had an equation, and Jaden, do you have a copy of these notes? You were here yesterday, right? Yeah. The green? Okay, I couldn't remember if you were here yesterday. So, sorry guys, I just want to check with him. And then we did it with an equation, right? Switch x and y, and then there was more work you had to solve for y. Okay, so today, let's talk about all these little bullet points. If f and g are inverse functions, then g of x equals inverse f of x. So what that means, let's put that in English, the last example I did yesterday, you were given f of x and you were given g of x, remember? And you had to do f of g of x and g of f of x, meaning you took g of x, put it into f of x, you took f of x and put it in g of x, those two separate times, simplified, and they both simplified to x, which made them inverses of each other. So what this is saying is if we did that, or if you're told here's two functions and they're inverses of each other, you could then call g, use that symbol, right? G of x is the inverse, which is this symbol. Anytime we see that -1 exponent on the variable, f, whatever the letter is, we know that's inverse switch x and y in whatever form, okay? Like we keep saying, if x, y is a point on the graph of f of x, then yx is a point on the graph of g of x. Remember, g of x is the same in this circumstance that we're talking about as that, right? This is the inverse. With inverse functions, all of the x and y values are switched. We talked about that a lot yesterday and already today. So the graphical behaviors, so on a graph, they also switch, like domain and range. Things I just said yesterday, domain is x's, range is y's, right? This is something we didn't talk about yesterday, and I really had never thought of this fact. I think this is a really, really cool idea. I'm going to explain it really better in a second. This would be a great way to just kind of eliminate certain questions. Here's what I'm getting at. Let me read it, then I'll put it in English for us. A continuous function will only have an inverse function if it is strictly increasing or strictly decreasing. If a function changes from increasing to decreasing or vice versa, it will not have an inverse. Okay, let's just say that. It will not have an inverse function. It's not invertible. So what is that talking about? So let's talk about a line, for example. A line with a positive slope, that is strictly increasing. A line with a negative slope is strictly decreasing, right? It's not going to suddenly, you all know this, it's not going to suddenly like get to a certain point on the graph and turn, right? It doesn't. It goes in this direction forever and ever and ever. There's no min or max in a line. There's no turning point, right? That is, so for lines, they are invertible. Remember that word. Invertible means its inverse is also a function, okay? There is that exception to the rule we talked about yesterday. Horizontal lines are a function, but horizontal lines are not invertible, Because remember, if we graph this, switch the x and y's, and graph it again, we get a vertical line, and vertical lines are not functions. So let me say it again. Horizontal lines are functions, but they're not invertible, meaning their inverse is not a function. Okay, so there's an exception to that rule, but for the most part, lines are invertible. Okay, let's talk about another type of graph that we work with all the time in this class, and that's parabolas. You know, from quadratics, x squared, right? A parabola looks like a smile or a frown, right? Are these kinds of graphs strictly increasing or strictly decreasing? Are they? No. We decrease, we hit a minimum, and then we increase. There's a turning point called a min or a max. These increase and decrease on the domain, okay? So parabolas are not invertible, ever. Here's why. If I took all the points off of a happy smiling parabola, I flipped them and graphed them, it would look like that. And just with base, like JV math language, that red graph does not pass the vertical line test. This is not a function. This is a function, but this is not a function, meaning the purple one is not invertible, okay? Same thing here. If I took all the points off a frowning parabola, flipped them, graphed them, it would look like this. Again, not a function. So parabolas are not invertible. Even though they themselves are functions, their inverses are not functions, okay? And there's one more type of graph we talk about in this class a lot, and that's exponential functions. They look like a J or a backwards J, right? Are exponential functions, think about it, strictly increasing or decreasing? Yeah. It's kind of like a line with a little curve in it, right? There's no min or max. There's no turning point in an exponential function, right? It is strictly increasing or decreasing. So the inverse is a function. So exponential functions are invertible. So it's just something to think about. I can't think of a situation where this would come up right off the top of my head. But if you had a multiple choice question, I'm not trying to give you a hint. I'm just kind of saying, if you had a multiple choice question, it was like, which one of these is not invertible? You might now be able to say right away, if it's a parabola, it's not invertible for the reasons we just talked about. Okay, so I just thought that was interesting. I'd never kind of pieced that together in my own brain until this year. Okay, all right. So what are we doing today? Really, really simple, okay? We're working with tables and graphs, that's it. You don't have to do anything with equations. And it's all about being able to read the notation and answer the questions, okay? So it sounds pretty easy. It is pretty easy. All right, so here we have a table of values for f of x, right? Here's the x values. These are the y values of f of x, right? These are a bunch of ordered pairs. And it says let g be the inverse of f of x. So g of x is the inverse of x. That's what that's saying. Okay? So this is the inverse. So let's look at what our first question's asking us. When you see this notation, it doesn't say what to do. We should be able to look at this and interpret the language, which is, this is your composition, f of 0, where you're taking f of 0 and plugging it into f, right to left, okay? That's something we did on our last test. Not difficult for any of you. But let's remind ourselves, when you see that 0, what letter does 0 represent? X, right? This is f of x, right? When we see an f with a number here, it is x, always. So what is it asking for? When x is 0, y is 1, okay? So f of 0 is 1. Now plug it back in to f again. Don't forget, this right here is x. So when x is 1, y is negative, right? Nothing new there. Now, if I see g, what the heck is g? There is no g. But remember the directions told us that G is the inverse. So if we are talking about an inverse, remember what we have to do? What's the base concept of inverses? Is switching x and y. So if this letter is x in the function, this letter is what in the inverse? Y. So that goes for, in this problem, they call G the same as the inverse. So when I see that, I know I'm talking about the inverse, so this is the y value. So when I go to this function, I go to the y value of -3 and grab the x value. Okay? Let's try another one. Again, if it confuses you, you could rewrite it like this. G is the inverse function. Okay? These mean the same thing. Right? So when you see that symbol, that -1 exponent, it means flip. So, or switch, I should say. Switch my x's and y's. So I know now that this is y, and I'm trying to find x. So when y is 6, x is -3. Doing okay? G of -1. -1, x or y? Tell me. Y. It's that easy. Is it x or y? Go find it. Y is -1, x is 1. 1 is x or y? It's y. Y is 1, x is 0. Are we seeing it? Some people were confused. Some people are like, this is so easy, I can do this in my sleep. And some people were still confused. Now look at this next one. This symbol, again, we should be able to look at this and know exactly what it's telling us to do. It's just like A written in that other form. That's that F inverse of F of -2, right to left. That's what that means. Okay? So if it's just F, this is your X value. So when X is -2, Y is 3, right? F of -2 is 3. Now what do they want us to do? Inverse. When I see that symbol, I know that this number in here is y. So when y is 3, x is -2. One more with this problem. -3, x or y? Y. Y is -3, x is 4. Okay? Let's do the same type of problems, but with a graph. So here we have K. Here's my graph of K. Inverse K would be all of these points flipped, right? So I have a whole bunch of ordered pairs for K. If I want the inverse, I would flip those ordered pairs, okay? So I'm actually going to do part B first. So again, when we see that symbol, we know this number is y for both of these, right? So on a graph, go to where y is 6. So on my graph, y is +6 right here, right? Look left, look right, find a point, there it is, that has 6 as its y value. Is that 11? Sorry, 11, 6, right? That's that point. So what is the x value when y is 6? 11. Y is 4 right here. Look left, look right, find a point that contains 4 as its y value. That would be 6, 4. Okay? Do we get that? All right, now, part A, let's go back to. What is the minimum value of k of x? All right, minimum is the smallest y value, okay? Maximum would be your biggest y value, okay? Again, we're talking about y values. Why? Because we're talking about how high or low we go, right? Most of the time when we're doing anything with graphs, we're talking about intervals, concavity, increasing, decreasing, all that stuff. We talk about the x's. This is the only time that I can think of off the top of my head that we use the y values to name it. So if I wanted to know what the maximum, so just ignore this question. If I asked you, what's the max of this graph? What's the max of the graph? Somebody tell me? 6. It's the highest y value we use. What would the minimum of this graph be? -3, right? It's the lowest y value. Now, what if we're talking about the inverse? So minimum and maximum of the function was the y value. Remember our concept? Flip. So when we're talking about the minimum or maximum of the inverse, we're now asking the minimum or maximum what value? Fill in that blank. X value. So this would be, what is the minimum x value? Because it's the inverse. You flip your x's and y's. So go to your graph. On the x-axis, the smallest x value we use is -4. Okay, oh, I forgot to write the minimum of this one was, sorry, you guys said it, Haley said it, -3. So the minimum of the graph, the actual graph, the lowest y value was -3. Of the inverse, then we look at the x's, was -4. We're going to do another one of those on the next page. Okay? Stay with me. Another graph, okay, graph of f of x. What is the maximum value of the inverse? So since it's an inverse, it's the x value. What is the biggest x value? 8, right here. Okay, we're just flipping. Yeah. Guys, see if you can answer B, and I'll check it with you. No calculator. Okay, so this would be y, this would be y. What did we get for inverse of 3? Should be 2. Check your graph again, Zach. How about this one? 3. What? Is it too small? Sorry, guys. Sorry if it's too small. But yeah, y is 3 right here. X would be 2. Oh, okay. All right. Okay, domain. If I ask for the domain of this graph, okay, I'm just going to do it because we always need practice with this. The domain of f is from -2 to 8, right? Those are the x values used on this graph from left to right, -2 to 8. The y values would be least to greatest from -3 to 7, right? That's the domain and range of this graph. What if I ask for the domain of the inverse? Flip. So when I want the domain of the inverse, it's really the range of the function. Remember, everything flips, switches. Does that make sense? We talked about it yesterday. So if you can find the domain and range of the function, the inverse flips these. Okay, so this would be the domain of the inverse. This would be the range of the inverse. Okay? Last one, putting it all together. Let's use a graph and a table and really mix things up. Okay? So here's g of x, here's h of x. Notice all the labeling, guys. That's why we have to use the names of these functions, because they have different names. And it tells you where to look. H of 6, that means x is 6, right? If you don't see the -1, it's plain old h of x. So h of x, h of 6, go to my h graph function. X is 6 when y is 10, right? Then it wants g of 10. G is right here. Okay, G is right here. And there's no negative there, so this is actually x, right? So when x is 10, y is -1. Right? That point is 10, -1. All right? X here, h of 0. So in my h function, x is 0 when y is 3. Okay? 0, 3. Now, I see that -1. I know that this is y. So go to the G graph. Y is 3 when x is 4. 2 more. G of 8, x. G of 8 is what? 0. I see a negative, that means this is y. Go to the h function. When y is 0, x is -1. One more. Don't let all those little negatives freak us out. One at a time. In the G graph, -1 is y, right? So on the G graph, here's -1. X would be 10. Okay. What else do you want? Inverse of h means 10 is y, would be 6. Guys, what if I gave you this, though? Because you're going to have one of these in your homework. What if I gave you this? This is y. So what is the x value when y is 13? We don't know. We don't know. So you would write not possible. Okay? So if the information is not there, you don't make it up. You say it's not possible. You can't trick me. Nope. Okay? That's it. B15 should be your last page. I don't know. Forget that. I don't know what it is. All of them, 1 through 22. The homework matches the notes exactly. Same order and everything. Same types of problems. 1 through 22, all of them. It should say B15 at the top. It should be the last page you haven't written on. Okay. Guys, don't just copy the key. Please, please, please try. You can have today's notes if you want. I mean, you definitely want to do it or whatever, but I could fill those out some way. All right, I'm going to do extra.